right, my name is tdot. I'm a software engineer at Lattice. Yeah, I'm about to talk about, bring you on our journey, basically building the best infrastructure for autonomous worlds and mud apps. Okay, so I will start by talking a little bit, bringing a little bit of context for those who don't know what mud is and what are autonomous worlds. I will then kind of describe some design patterns that we learned about while we were essentially solving problems for mud apps and how basically we solved them. And then I'll be describing a new system that we're prototyping. You might have gotten a sneak peek already if you caught Alvario's talk earlier on mud. So yeah, stay tuned. Okay. So if you're not familiar with Lattice, we've been promoting a vision for on-chain games to basically develop properties of a thing that we call autonomous worlds. Who here knows what autonomous world is or has an idea? Okay, that's quite a lot of people. Who knows about mud? All right, that's good. But so we're all on the same page. I'll give my quick definition of it. Essentially, whoa, things are moving. So when I say autonomous worlds, what I mean is like permissionless virtual worlds that are seeded by initial teams who are then joined by early adopters who build on top of it until the plot evolves beyond anyone's single control, and then complex drama and social components emerge. And to enable autonomous worlds, we've built mud on Ethereum so that world builders could have robust primitives to implement their vision and build fully on-chain gaming loops. And then on-chain games are, well, too expensive to run on Ethereum mainnet, so we needed a cheap chain with big blocks and infinitely scalable DA. So we basically added that feature to the OP stack and deployed it as a chain called Redstone. And on top of Redstone, we're also running free services for mud apps like public RPCs and indexers. And actually, to give you a little context, this is a screenshot of Conduit's public rollup dashboard. And if you look at the top 6 L2s, you can see, except from base, all of these L2s are mostly focused on on-chain games. So these are like all the megagas per second that is here. So all these rollups are ranked by megagas per second. And you can see all of them that have extremely high megagas per second are basically have on-chain games deployed on it. And actually, it's kind of interesting too, is Redstone doesn't have that much transaction per second, but its megagas per second is very high. That means that mud transactions are actually storing a lot of data on chain, so they're actually quite big. So that's why we needed Redstone, so to have a chain with very big blocks and a lot of gas, and so that mud apps would stay cheap. So some applications that launched on, or are about to launch on Redstone, if you haven't caught the Eve talk earlier by Hilmar and Justin, but I'll talk a little bit. Eve Frontier is a part of the Eve Online universe. So they designed an incredibly sophisticated world physics and are progressively bringing components on chain over the next few years. You know, they're here for the long term. So builders can basically implement business logic permissionlessly on top of it. So if you missed the talk earlier, I recommend you go back and check it out. And then Biomes is bringing Minecraft physics on chain with new types of creative gaming loops. And they have very intensive requirements to enable multiplayer. They're currently on Redstone mainnet. Actually, most of the gas that you saw on the dashboard earlier is coming from Biomes. So very excited about this world. And while these teams develop the physics and they seed the worlds with the origin stories and the gaming loop, it is when people can build on top without permission and extend the world with new experiences that properties of autonomous world really emerge. So we like to call more technical users who extend the worlds sewage hackers, because they get their hands dirty and they need access to lower level infrastructure primitives, such as indexers, RPC APIs to power their applications. And you know, it's like most inhabitants of a city, they don't need, or they don't concern themselves with the sewers, but they're a crucial part of these very dense environments. If your sewers stop working, your you're pretty fucked. Okay, so I'll go over some requirements. We want to enable worlds where multiple players can interact with the state at the same time. We want low friction for inhabitants so that they don't have to pay expensive transaction fees. We want to stay EVM compatible so that apps can be compatible with other chains and other tooling that's in the Ethereum ecosystem. And lastly, we want this to be super easy for MUD users to integrate, so they shouldn't have to rewrite their apps or add complex client logic. If you're using MUD, all the tools that we built work out of the box. Okay, so one of the things that we worked on was enabling MUD apps to deploy on mainnet with a future-proof data availability solution. So we actually worked with Optimism to, we designed and we implemented a Plasma DA protocol in order not to use blobs. There's actually a talk right now in the other stage where they're discussing, are blobs cool? We thought blobs are not that cool. So, we like blobs, but we wanted something that's more future-proof and infinitely scalable if you had more chains. And so we worked with Optimism and to upstream this in the code base. And this is known in alt DA mode. And our specific DA layer uses a Plasma-like design so that stakeholders can have an emergency exit hatch where they can challenge data if they believe the data is missing. And you can basically keep the chain running while you withdraw your funds. And if you want to know more about how this system works, I recommend you check the Optimism specs. Actually, a fun fact too is once we decided to launch Redstone, we were doing some load testing and we ended up breaking the chain on testnet because we had too much data. And we started with a very large block size, 100 million gas, and the OP stack limits were not large enough to enable this kind of payload size. So we actually collaborated with the OP stack core developers to raise this limits that was introduced in the Shard network upgrade. And it was really easy to ship quickly because we control the full infrastructure by running the chain ourselves instead of adding intermediaries like roll-up as a service providers. So it allows us to make custom changes to the services and test potential protocol changes directly so we can observe the effects on application directly before they eventually get upstreamed in the OP stack. And when we started running the L2 chains, so we had to learn how to run the chain and do all that stuff. And we quickly ran into bottlenecks because our sequencer node was busy building blocks and handling RPC requests. So we did some basic things like separating the read and the writes. And essentially, eventually the Redstone sequencer stayed private. We exposed another one that was synced over peer-to-peer. Then that node also got a bit overwhelmed, so we added another node and split them by regions. Now the problem you face, and actually you might have heard Ryan talk about it in indexing, is you can end up with different states if you have a load balancer in front of your nodes. And there's actually really cool ways that, for example, Optimism implemented a proxy D which helps basically keep a health check loop, so you can check that each of the nodes has consistent state, and you remove them from the set if they're inconsistent. You have other goodies like caching and rewriting reorgs. And eventually, we also wanted to have better latency inside of different regions, so we added, DNS load balancing, so you can see here our user is in the south of France, he gets redirected to the closest region, which then goes to our proxy and load balancer and a bunch of nodes. So this is things that we implemented. Another aspect, and if you heard Ryan's talk earlier, you already probably know how to implement your own indexer. But actually, a common bottleneck is experienced by MUD application is when the state grows and users grows, the initial load of the game can be very slow, especially when it's hydrated directly from a node RPC. So this is solved by loading the initial state from an indexer database. We first released an open source version of the indexer, so apps could index their own world. And we also wanted to offer free indexing for all the MUD applications. And our first indexer implementation was kind of not as performant. It had limitations, so we collaborated with Ryan, actually. And Ryan ended up building most of the indexer that we're actually running now. And it can scale for a whole bunch of worlds. So, yeah. Okay, another aspect that I learned about recently myself is how Ethereum providers, like browser clients and things like that, they make a lot of requests by default before sending a transaction. And if you're far from the RPC server, the latency can add up. Some of these requests, like estimate gas, they're also quite slow because they run the EVM quite a bunch of times to estimate the gas. So we made some optimizations. You can see here, it's just all the, by default, you can be making as many of these requests, and so that ends up pretty slow. So we made some optimizations on the MUD browser clients. So we added a nonce manager, which only syncs with the RPC when you need to. We made sure that transaction context is preloaded, so when you click, you're only sending the transaction, you're not doing a bunch of other things, so that it feels kind of snappy. And we're also caching gas estimates, so we don't actually need to call estimate gas every time, and things like that. But, you know, however you spread read nodes across the world, if you're using an L2, at the end of the day, transaction confirmations will always be the fastest, the closest you are to the sequencer. And you're going to have to wait for the block time before you actually get your confirmation. So if you're running a sequencer in Europe, users in California and Japan are getting pretty awful performance. And the experience playing the game can be very different from users who are close to the sequencer. So what can we do to improve this? You know, how do we scale block building? So one way we could do this is we could have multiple chains in multiple regions. Maybe they could even be L3s, you know? Or, I mean, that could work maybe with Optimism's interop protocol, if we want to bring block buildings very close to the user. But there's going to be a lot of chains. You know, you don't want to be running tons of different chains in all these different regions, especially when maybe your users are moving. So you just want to be loading block building at the edge wherever you need to. So what if we could run block building at the edge when needed, just for a piece of state? And for example, imagine you get matched with different players in your area and you start an ultra low latency game match. And so I will preface this by saying this is probably not the only solution, but this is the one we're currently validating as a prototype. And so I'll try to explain a little bit how this is made. So if you remember the previous here, we're like actually deploying block builders directly on the edge. And we call them points of presence, like for CDNs. And what they do is essentially they act like a full Ethereum RPC, but they only pull the state they need from the upstream. In our situation, the pubs, they just request the latest version of the state. And if we need to write to that state, a point of presence can then acquire a lock on it. And this is handled at the MUD level, because we have static ways of determining, you know, which MUD table the pub needs to write to, and then only that pub can batch transaction to modify that state, and then they can send the confirmations immediately without waiting for the actual chain payload to be built. So pub builders can send in transaction batches to the upstream eventually, just in time before the block get built, and then no other pub builder can modify that state. So, and then, you know, you have basic CDN stuff like the state locks are cleared, you know, on least recently used basis, and they're automatically cleaned up once you have more data that comes in and your data has been stale for a while. And then these are other examples of things that you can speed up once you can run them on the edge. For example, when you're estimating the gas or you're managing the nonces. And so you can have extremely precise gas estimates by running them directly on the edge. You can have fresh nonce management when you're syncing it. And you can even do ERC 4337 user op bundling on the edge. And so, I mean, this just accelerates a lot of things. And we were when we were testing this, it actually ended up getting to a very, very good performance. Actually, I'll show you a little demo. I don't know if I press play, this will work. Okay, cool. So we implemented this game just to demo this prototype. It is multiplayer. Every time you move the fly, this is a transaction that is executed and a receipt that is sent back to the browser. So you can see like all of these 20 milliseconds here every time you're executing a transaction and getting the receipt back. And so I mean, this is still a prototype, but if you want to learn more and get to know, actually test the thing yourself, get a feel for it, you can come to MUD Day tomorrow and actually experience all the games or learn more about how all these things works. All right. Thanks for listening. No question yet.
That was a great presentation. I noticed that no one had any questions in the Q&A. Oh, it's coming? Okay. Because I was going to front run you guys. No, 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 no. Audience first. Oh, man. Okay, I'm going to ask my question then to fill the time gap. Okay, so this seems really awesome and amazing. But given my background, I do a lot of security research. So all I see is, oh my God, scaling extremely quickly. What are your thoughts around security?
I mean, obviously, you have all the security assumption of the Ethereum protocol, which are respected. You know, we're part of the super chain. We're trying to do all these upgrades. So everything that is basically touching the Ethereum protocol has the guarantees of alt-DA chains from the OP stack. And, you know, all of this is audited or like is reviewed by the OP stack team. And then on the things that we control, then it looks more like Web 2 security, where you have your servers and your DNS and TLS, all that kind of stuff. So you do have different kind of areas, and we have different ways of solving these problems that are more specific to either Ethereum protocol or basic services, hosted services.
Gotcha. I have a lot more questions for offline, but any other questions since then? Okay. I'll go for the first one here. So how are you in the super chain with a custom DA?
I mean, we're not in the interop set just yet, so I guess this would be the kind of slight differentiation. But we're still kind of, so we're not part of the upgrade set, so we don't get the basic rollup upgrades. But we're in the super chain per se because we're actually using the upstream protocol version of the protocol. We're not running a fork. And so all the code that we run is basically reviewed by the OP stack core protocols.
What's next on the roadmap for MUD? What features are most needed next?
I mean, I can speak for the infrastructure part of things. Yeah, what we're really trying to do here is get to these extremely low latency and get those on mainnet. So we're trying to get, the new indexing. We're trying to get all these things available on Redstone mainnet. And then probably the next thing that we probably will be working on is, integrating interop, so Optimism's multi-chain protocol inside of MUD. So we'll also have some exciting things like this, but this is still work in progress.
Gotcha. Yeah, that speaks to my question of why you joined the superchain. How do you balance the benefits of scaling and the latency optimization against the dollar cost?
Yeah, that's a good question. I mean, one thing we've been trying to do is move towards a more bare metal server architecture. So instead of using AWS's very expensive servers, we're trying to run things on different bare metal providers that are cheaper and have a lot of redundancy because they're obviously less stable. So that essentially, if a region goes down or a server goes down, if it's not as stable as AWS, the users don't really see the difference. And then basic stuff like bin packing, just adding a bunch of services run on the same machine. So you have all these optimizations that you can do. But yeah, we're still fine-tuning this part actually.
Okay, we got a question that's really popular. Can it run Doom?
Oof, that's actually a really good question. I think you should come to Mud Day to find out about that.
Can WoW be next? Next question, by the way. That was a joke. You didn't have to laugh. What's your thought on CRDT and CRDT plus blockchain? I'm sorry, I'm not the person to be asking that question.
I think it's an interesting question because it's like CRDT are used if you really want to do pure decentralization and you care about not having a single point of failure and having all the browsers be able to eventually reconcile the state and things like that. So I guess it would really depend on what your use case requirements are. If you're trying to build a game that is, even if all the lattice servers go down, you can still play the game, then CRDT could actually be a pretty good solution. But otherwise, I'm not fully certain that you can get the same kind of performance and latency that we have when we have these edge block builders.
Cool. Any other question, guys? I got one spicy question here. Oh, nope. Oh. Someone else has another question in here.
This is not a question.
CRDT is, yeah, someone has a point here to make. What is your take on that? CRDT is only for commutative operations, bad for games. Thank you for that spicy question, or opinion rather.
What was the other take you had?
Oh, the other take I had was, I'm curious how you actually see the difference between Ton Chain and all of their, fun mobile app games. I don't know if you guys have played any of them, but they're highly addictive. And you do end up earning whatever tokens in their ecosystems. And they seem to be building something quite similar, probably a lot less complex than what you guys are.
Yeah, I think, so it's quite interesting too, because what we're really focusing here is like autonomous worlds where you bring as much part of you're trying to bring all the physics on chain so it can live without anything on the client, and then eventually can live out, outlive the teams, outlive everything. And so these kind of games that are kind of addictive, they're not really geared for this kind of, long-term view or things like that. You really have the gaming loop, that's all that matters. Whereas here we're trying to have everything be on chain eventually, and that's what MUD is about really, is like enabling all these very complex physics fully on chain.
Gotcha. Okay. Thank you. Any other questions?